Alright, so in this game it looks like we have a sequencing setup in that we have 5 positions in a particular order that we have to fill. And since it's a sequencing game, we're going to let that drive the chart. So across the top we will have 1, 2, 3, 4, and 5. Now it's worth noting that the first 2 clues are actually what set up the game for us here. And the first clue tells us that the elements that we're dealing with are just 0, 1, 2, 3, and 4, while the second clue tells us that each of these guys only goes once in any code. And since we do have 5 positions available, that means that each of these guys will go exactly once. Now, the third clue tells us that the second digit has a value that's exactly twice that of the first digit. So essentially we can symbolize that as number 2 has to be 2 times of number 1. The last clue tells us that the value of the third digit is less than the value of the fifth digit. So essentially, number 3 has to be less than number 5. Now, in terms of deductions, it's worth noting that this clue over here, the one that tells us that the number 2 position has to be twice as big as the number 1 position, that doesn't really give us very many options. For example, number 1 could never be a 0 because then number 2 couldn't really be double that. We could have a 1 here and then number 2 would be a 2. We could have a 2 here and then number 2 would be a 4, but that's really it. We could never have a 3 here because there's no 6 available, and we can't have a 4 here because there's no 8 available. So really there's only 2 major possibilities for this clue, and in fact it might be worth to just try them out. We know that we can have a 1 and a 2 over here, or we can have a 2 and a 4 over here. It's worth also noting that no matter which one we go with, no matter what, the number 2 has to be in one of these first 2 positions. So that's just sort of something that you can take a quick mental note of. Now, the next clue tells us that the number 3 has to be less than number 5, and while that does give us plenty of options, it does give us a quick deduction that we know number 3 could never be a 4, and number 5 could never be a 0, just because 4 is the biggest number and 0 is the smallest number here. So with that in mind, we can go straight to the questions from here. Now, we don't have any rule exclusion questions here, so we can jump straight to our local questions. And the first of these here is question number 1. Now, question number 1 asks, if the last digit of the code happens to be a 1, what must be true? Well, let's see what we can do. If the last digit of the code happens to be a 1, right away we do know that number 3 has to be a 0 because number 3 has to be less than number 5. Now, we also do know that if the number 5 digit is a 1, then we can't have 1 and 2 across the first 2 positions like we did over here because we don't have a 1 anymore. So essentially this would have to be a 2-4 setup at this point, and the only remaining digit here happens to be a 3. Now the question of course asks what must be true. Answer choice A says that the first digit is 2, and yes, the first digit absolutely must be a 2. The best answer to number 1 happens to be A. Now, the next question that's local here is number 3, and it asks, if the third digit of an acceptable code is not 0, then what must be true? Well, let's see what we can do. If the third code is not 0, I guess the question becomes, what could the third one be? Well, we definitely know that it can't be a 4, as per our deduction up front, and we also said that the number 2 has to be somewhere in the first 2 positions, so it also can't be in 3. Now, if 3 can't be 0, that really only leaves 2 possibilities. It could be a 1, or it could be a 3. And since we only have 2 options, we may as well just try them out. So we know the 1 can go here, or the 3 could go there. Now, we do know that number 5 has to be greater than number 3. So if this is a 3 over here, then number 5 has to be a 4. And in this bottom scenario, we also know that since it can't be a 2-4 setup over here anymore, then it has to be a 1-2 setup over there, and number 4 has to be a 0 at this point. Now, in the top option, we do know that it can no longer be a 1-2 setup because we've taken away the number 1, So this will have to be a 2, 4 setup in this case. And we do also know that number 5 has to be greater than number 3, and the only number that's remaining that's bigger than number 1 is a 3, so we'll have to have that there, and that leaves a 0 for the 4th position. Now the question of course asks what must be true, and it's worth noting that in both cases a 0 is in the 4th position, so we can jump straight to answer choice C, which tells us that the 4th digit of the product code is 0. Now there was also a more efficient way to go about this. Since we did know that 0 cannot be in number 3, it's worth noting that it could never have gone into the first 2 positions, and it couldn't have gone into the 5th position either, so really the 4th position is the only place that a 0 could have gone. Now it looks like there aren't any more local questions remaining, so we can jump to the global questions, and with that we can start with number 2. Number 2 asks which of the following must be true about any product code. Well, let's see what we can do. We know that A says the digit 1 appears somewhere before the 2. Well, looks like in this scenario that necessarily was not the case. We know that 1 could have gone after the 2, so we know that A does not have to be true. Answer choice B says 1 appears before the 3, and again it looks like 1 could go after the 3, so B also does not have to be true. Answer choice C says that 2 appears before the 3, and looks like so far the 2 has appeared before the 3 every single time. Actually, if you take a look at our 2 possible templates over here, it looks like no matter where the 3 goes, it will end up having to be somewhere after the 2, because the 2 is either in this position or in that position, and the 3 would never be before it. So with that, we can actually go with answer choice C right away. Now, the next global question here asks us which pair of digits could be the 3rd and the 4th digit respectively. Now, the thing is though, we already have a whole bunch of data on what could go into 3 and 4. So for example, we know that 0 and 3 is definitely an option. And since that's what answer choice B says, we can cross off answer choice B right away. Likewise, we know that 1 and 0 is an option, so we can cross off answer choice C. And we also know that 3 and 0 is an option, so we can cross off answer choice D, which really just leaves us with answer choices A and E as the remaining contenders. Since we know that one of these will work and one of these will not, all we really have to do is just try one of them out and see what happens. So let's see what we can do with A. If we plug a 0 into 3 and a 1 into 4, right away we do know that the first 2 positions will not be able to be 1 and 2 because we already have the 1 taken care of here. So this will have to be a 2, 4 setup. Now we still know that the 5th one has to be greater than the 3rd one. So since this is a 0 and the only thing remaining is a 3, that looks like it works out because 3 is greater than 0 and then 4 is exactly double of the 2. Since answer choice A works, we can cross it off, and that just leaves us with answer choice E for number 4. For the record, the reason that doesn't work is essentially that if 3 is in the 3rd position, then the 4 would have to go into the 5th position, since the 5th position would have to be greater, which means that the 4 could not go into the 4th position in that scenario. Finally, the last question here is number 5, which asks which of the following must be true about any acceptable product code. Well, let's see what we can do. Answer choice A says there's exactly 1 digit between the 0 and the 1. Well, looking back, it looks like, for example, over here, we could have just had no digits between the 0 and the 1, so we definitely don't have to have exactly 1 digit between them. So we can cross off answer choice A. Answer choice B says there's exactly 1 digit between the 1 and the 2. And again, looks like over here that didn't have to be true, so we can cross off answer choice B. Answer choice C says there are at most 2 digits between the 1 and the 3. Now, so far it looks like we've never had more than 2 digits between the 1 and the 3, so I guess we can hold on to that one for now. D says there are at most 2 digits between the 2 and the 3. And it looks like in this scenario we've had 3 digits between them, so it looks like we don't have to have at most 2 digits between the 2 and the 3, So we can cross off answer choice D. Answer choice E says there are at most 2 digits between the 2 and the 4, and looks like so far we have had only 2 digits between the 2 and the 4. Now, it's worth noting that in this case, our two contenders C and E both tell us that there are at most 2 digits between two sets of numbers. But the only way we can possibly in this game have more than 2 digits between a pair of numbers is if we had the 2 digits at the very ends. So really, we just need to test for whether one of these two sets of digits could go all the way to the ends. For example, answer choice C says there are at most 2 digits between the 1 and the 3. Well, the question then becomes, can we have more than 2 digits between the 1 and the 3? That is, can we have 3 digits between the 1 and the 3? Now, the only way that would happen is if we put them into the first and the fifth position. That way there will be 3 digits in between them. Now, we do have the 1, 2 set up over here, so let's just try that and see what happens, since we already know that we could have a 1 in the first position. If we have a 1 and 3 over here, the question becomes, could it work? Well, if we have a 1 here, we definitely know that 2 has to go into the second position. Since we know that the number 3 position has to be less than the number 5 position, the only way that could work right now is if we had a 0 over here, and that would leave us with a 4 in the 4th position. Now, it looks like this does follow all the rules, so we can cross off answer choice C. That leaves us with answer choice E for number 5. For the record, the reason that we must have at most 2 digits between the 2 and the 4 is that if the 2 is in the first position, then the 4 has to be right next to it. But if the 2 is in the second position, there's no longer any possible way to have 3 digits in between it and wherever the 4 may go. So the best answer here once again becomes E.